we're going to talk about congruent triangles. So what does this congruent mean? Well, we all know that congruent means the same size and the same shape. Here I have two gray triangles. For reference purposes, I'm going to label the first one ABC and the second one DEF. You'll notice that I've color-coded the vertices in order to give us a better idea of which vertices go with which other ones. Angle A is marked with one arc mark. In the same way, the blue angle in the other triangle, D, is also marked with one blue arc mark. So what we can say is that angle A is congruent to angle D. Angle B has two arc marks. The same way in the other triangle, the green angle, angle E, is also marked with two arc marks. So what we say is that angle B is congruent to angle E. Angle C is marked with three arc marks. The orange angle in the other one, F, is marked with three arc marks. So what we say is that angle C is congruent to angle F. If we look at the sides, we notice that AB is marked with one tick mark. The same way, the side between D and E, the blue and green angle, is also marked with one tick mark. So we say that AB is congruent to DE. Also, BC is marked with two tick marks. EF is also marked with two tick marks. So what we say is that BC is congruent to EF. AC is marked with three tick marks. Also, DF is marked with two tick marks, so we say that CA and FD are congruent. When we have all three angles and all three sides in two triangles that are congruent, we can say that the two triangles are congruent. A and D go together. They're in the same relative position when I name the triangles. In the same way, B and E are together. They are the angles that are congruent. Also, C and F are congruent. So what we can see is that AB, the letters next to each other, and DE in the same relative position are congruent sides. Also, BC and EF are congruent sides, as are CA and FD. That's what it means to be congruent. All angles and all sides in the same relative position are congruent. Now I want you to look at these two rectangles and notice that ABCD is congruent to EFGH. It's going to mean 8 separate things, 4 sides and 4 angles. See if you can outline what that means exactly with 8 congruent statements. In this example, we're going to look at two triangles that are sitting right next to one another. We have a congruent statement here that tells us about the two triangles. Now you'll notice they share two vertices, but this still means that angle E is congruent to angle G. It means that angle F is congruent to angle F, and it means that angle H is congruent to angle H. It also means something about the three sides. So, watch how I do this. EF, the side, is congruent to, so that was the first two, so that means it's congruent to GF, the first two. So that means that FH is congruent to FH, not surprisingly. And it means that HE is congruent to HG. And so if I mark that in this diagram, EF and GF and HE and HG, and this one is congruent to itself, and I can also mark the angles congruent. And what I'm going to notice here is that when I get down to this area here, I have a congruence that can be made. So now let's look at this. I have these two triangles. Now normally I'd have to say EFH for this angle. But if I'm considering them as two separate triangles, angle F for triangle 1 is this one here, and for triangle 2, angle F is this angle here. So if I'm considering this triangle and I see angle H is congruent to angle H, this angle is congruent to this angle. So 6x minus 12 is equal to 90. If I solve for x, I can find out that x is equal to I can find out that x is equal to 17. In order to find the value of GFH, which is GFH, I need to do a little bit of figuring. Now, I know that this angle here is 90. So what I can do is, I can fill this in with a 90-degree mark. How does that help me? Well, it doesn't necessarily help me, except for the fact that I can find this angle now. The angle up at the top here, angle F in triangle 1, is going to be equal to 180 minus 90 minus 21.6. When I figure that, I get 90 minus 21.6. I get 68.4, which isn't particularly significant, except for the fact that I know that angle F is congruent to angle F, which means that the 68.4 goes over here as well. I still want to find GFH, which gives me 68.4. Because all of the pieces of one triangle are congruent to all the pieces of another triangle, the two angles are congruent.